Hey guys, this is Dr. B, and in this video I'll show you how to convert an initial value problem into an algebraic equation in the Laplace domain. So here's the problem that we'll be working on. Transform the initial value problem y double prime minus y equals negative t with initial conditions y of 0 equals 0 and y prime of 0 equals 1. And we want to transform this into an algebraic equation in the Laplace domain. So to do this, what we'll do is we'll take the Laplace transform of both sides of this differential equation. So we'll take the Laplace transform of y double prime minus y, and we set that equal to the Laplace transform of negative t. So the first thing we'll do is we'll use the linearity of the Laplace transformation to split this up here. So we get, let me use another color here. We're going to use the Laplace transform of y double prime, and then we're going to subtract from that the Laplace transform of y. Y double prime, subtract Laplace transform of y. And then on the other side, we can pull out the negative 1, a factor of a negative 1. So we get negative the Laplace transform of t. Now, to simplify the Laplace transform of y double prime, we need a property of the Laplace transform, and we can find that over here. So here we see two properties for Laplace transform of y prime and the Laplace transform of y double prime. And so what we're going to use here is this identity here. The Laplace transform of y double prime is s squared times the Laplace transform of y minus s times y 0 minus y prime of 0. So let's take that first part, right? Put it in a box and rewrite that. So we get s squared times the Laplace transform of y minus s times y of 0 minus y prime of 0. So that's just that first part. And then we subtract the Laplace transform of y. And for ease of notation, I'm going to denote the Laplace transform of y by a capital Y of s. So subtracting the Laplace transform in our new notation, that's capital Y of s. And then that is equal to negative the Laplace transform of t. Now for that, we can use this property of the Laplace transform. So the Laplace transform of t to the power n is n factorial over s to the power n plus 1. And we just have t here, so of course we can think of this as t to the power 1. And so our n in this identity is 1. So we get 1 factorial, which is 1, and then s to the power 1 plus 1. So the final answer is minus 1 over s squared. Okay, let's clean this up a little bit. So we have s squared times the Laplace transform of y, and we're using y of s for that. Then minus s times y0, and y0 is an initial value. We see that y0 equals 0. So oops. So that is minus s times 0. And then we have minus y prime of 0. So we get minus y prime of 0 is equal to 1. So we get that that is 1. And then we subtract y of s, and that is equal to negative 1 over s squared. So we can clean this up a little bit more. We see that s squared y of s, and there's a y of s here. We can think of this as negative 1 times y of s. So combining those two terms, we get s squared minus 1 times y of s. This, of course, is 0. And then the minus 1. This is minus 1 here. And the right-hand side is negative 1 over s squared. So let's go ahead and solve this for y of s. So the first thing we can do, of course, is to add 1 to both sides. And that then gives us s squared plus 1 times y of s equals 1 minus 1 over s squared. And to get y of s by itself, we can divide both sides by s squared plus 1. Now that is a fraction in a fraction, and if we want to clean that up a little bit, we can multiply by hidden 1 s squared over s squared. And you see, if we distribute that over the top, the numerator, you see that gets rid of the 1 over s squared in the numerator. And what we then have is s squared. Oops, I see that my s squared minus 1 turned into an s squared plus 1. I apologize. That's s squared minus 1. And then s squared minus 1 here. And so when we distribute this, we get s squared minus 1 in the numerator. And that's something that I had in the denominator as well. And so I'm not going to distribute the denominator because now I see there's a factor of s squared minus 1 here and a factor of s squared minus 1 here. And when those two cancel, of course on top you just get a 1. So the final answer is 1 over s squared. So the Laplace transform of y is equal to 1 over s squared. And so in the next section, we'll see how we can apply an inverse Laplace transform to see what this means for y of t. Right, so we're going to apply an inverse Laplace operator and get back to the t domain. And then we also want to find the inverse Laplace transform of this guy. And then we get a solution for y of t. And so what we have done then is we've transformed the differential equation into some algebra here and did some more algebra and finally found an expression for y of s. And then we can transform that back into a solution for the differential equation. So that's something that we'll see how to do to find an inverse Laplace transform of an expression.